ในข้อเช้าข้อเช้าด้วยโดนแน่โดนแน่โดนที่หัวแน่ข้าวข้าวไม่เข้าขนาดนั้นโดนอีกคนเชื่อไหมถ้ามันโดนลูกซองเนี่ยแบบมันจะเป็นไม่แล้วไม่มีเลยเราไปมันก็เข้าไปด้วยจริงด้วยได้ยังไม่เข้าเลยโดนไม่เข้าในโทรศัพท์จริงๆของ
Good morning. Good morning, Otto. Good morning, Kaimo. Good morning, Sirat. Okay, so I will take your attendance, all right? Okay, what date is today? 9. All right. Okay, I can only see 2, 3 of you guys. Anton, Crow is not here yet. Tata, Opur. I saw Opur. It's gone now. Okay. P. Online. Everyone's online. Kaimuk.
Present.
All right, present. Otto. Yes. Present. Wait, sorry. Feng Fu. Online. Cao Klong. Okay. Alex. Someone just oh, hey, Alex. Matthew. Offline. Okay. Best base or best base. You? Okay. Dean. Plawan. Online. Win. Pat. I don't see Pat yet. Pang online. So online students, have I missed anyone's name? Okay, Pat. I saw Pat now. Have I missed anyone's name? Sirirat. Where is Sirirat? What is your number?
Sirat is Pang.
Oh, okay. Okay, I haven't missed anyone's name, right? Online students? Okay, so let's start with our class then. All right, so I'm gonna share my screen. Okay, let's try to remember what we have learned in our last class first of all. In our last class, we have started with new chapter, right? Can you all get your science book? 67. Okay, can you all get your science book? On-site students, get your science book. Page number 67. So in our last class, we have started with new chapter, right? Which is about waves. Okay, so I'm gonna re-explain it, but it's gonna be a little bit faster, okay? Let's try to remember what we have learned in our last class. So in our last class, we have started with new chapter, page 67. So what is wave? Oscillating source. So do you guys remember the word? What does oscillating means? In English? How do you say in English? Oscillating source means moving source, okay? Moving source, all right? So a wave is a traveling distance from a vibrating or oscillating source is called as waves, all right? So as the wave travels, it carries energy along with it, right? And it spreads in the direction of propagation. So the word propagation means in the direction of the wave, in the direction where the wave is spreading is called as propagation. Understood? So the examples that I gave you was the water droplet, right? So this water droplets, when it falls into water, what does it create? When the water droplets drop inside the water, what does it create? Wave. It creates wave, right? So likewise, another example is the ball. So when I drop a ball in the water, it also creates the wave as well. All right. So some of the water, when we drop the ball inside the water, so some of the water is being pushed aside and raised by the ball. Okay. So the ball doesn't travel with the wave, but the energy of the wave just passes through. All right. So these are the examples. So do you want to read in the front? Last one? Seismic. Okay, very good. So these were the examples, right? These were the waves that include. Okay, and do you guys remember we learned about this one as well, right? The wave can be, these waves, right, can be grouped into two types. So what are they? These waves can be grouped into two types. What are they? Let me ask online. Okay, Kaimuk. Hello, Kaimuk.
Yes.
Okay, so these waves, right? Sound wave, light wave, radio wave, and seismic wave. This can be grouped into two types, right? On-site student silent. So what are they? Kaimuk, did you get my question?
Yes, but I don't know.
You don't know? Who knows the answer? Pat. Okay, yes. Longitudinal wave and transversal wave. So you guys remember last time I used the slingy coil, right? To show you the wave, right? Slingy coil. Do you guys remember the slingy coil? I took it from there, slingy coil, the coil. So I showed you with the slingy coil, right? The wave, how the wave forms, right? Okay, so all the waves can be grouped into two kinds. So what are they, Otto? Can you please read it? Otto. Hello, Otto. Louder, please. Otto, teacher cannot hear you.
Yes, I can hear.
Yes, all the waves can be grouped into two. So can you please read what are those two waves? Can you please read this?
One
Transversal wave.
transversal wave
Okay, another
So
longitudinal wave. Okay, Otto? Transversal wave and longitudinal wave. Okay, so this is just like a revision for you guys because we learned this last time, right, in our last class. So transverse wave is a wave that has vibration in direction perpendicular to the direction of the wave. So you're allowed to turn on the AC, right? Okay, thank you guys. So in the transversal wave, okay, sit. Thank you. Okay, in the transversal wave, what is transversal wave? So transversal wave is a wave that has vibration in a direction perpendicular to the direction of the wave. In the front, can you please read the sentence? Yes. Transversal wave. Vibration. Direction. Perpendicular. Direction. Okay, so did you guys get it? So transversal wave is a wave that has vibration in a direction perpendicular. So what does the word perpendicular mean? Do you guys remember? What does the word perpendicular mean? Yes, 90 degree, right? Up and down, 90 degree. Very good. Okay. So transversal wave falls in a perpendicular direction. Okay. So can you all see this direction? It's up and down, right? Up and down. Okay. So the examples are water wave and electromagnetic wave are the example of transversal wave. All right. So this is how the wave flows. Okay. Last time I was trying to draw, but then this time I got a picture for you guys. So this is how the transversal wave flows. All right, everyone? This is perpendicular. All right? Okay. Number 2 was about the longitudinal wave. So longitudinal wave. Okay, I want someone to read. I want Alex to read. Alex, can you please read the sentence?
Longitudinal wave. Longitudinal wave is a wave that has vibration in a direction parallel to the direction of the wave.
Okay, very good, Alex. Okay, longitudinal wave is a wave that has vibration in a direction parallel to the direction of the wave. So what is parallel here? Yes? Sideways, right? The word parallel means sideways, okay? So in the longitudinal wave, the wave flows sideways, okay? Sideways. Whereas in the transversal, the wave flows in 90 degree or up and down, okay? So the example of longitudinal wave is the sound wave, okay? Sound wave is the example of longitudinal wave, okay? Oopsie, let's go to next one. Sorry. Let me stop sharing here. All right. Hold on, online students. Okay, this is longitudinal wave. Example is sound wave. So this is how the wave flows in longitudinal wave, all right? So the direction will be, the wave flows in a parallel direction, all right? Do you guys remember? I told you guys to read this, right? I told you guys to read this. Do you guys remember? So the key terms, amplitude, crystal, wavelength. Okay, so I'm going to ask you guys a question here. All right. So amplitude is the height of a wave from the middle line to the crest or top is known as amplitude. So crest is the top of the wave and top is the bottom of the wave. All right. Whereas the word wavelength is the distance from the point on a wave to a repeating point. So when the wave flows, right? The wavelength is the distance from one wave to another wave. It's called as wavelength. All right, everyone understand this? Okay, teacher is going to ask you guys question here. Let me ask this to online students first. Prow. Hello, Prow.
Yes.
Okay, so let me ask you the first one. Okay, what is this? Sorry. Woohoo. Okay, hold on. So please, you're going to tell me which one it is, okay? So I'm going to show you the example here of the wave. This is a transversal wave, okay? Example of transversal graph wave, all right? So can you tell me, what is this? This part. Proud, can you tell me what is this? Do you think it's crest? Do you think it's top? Do you think it's wavelength? What do you think it is? Okay, on-site student, what do you think this is? Huh? Chest? Crest? Do you mean crest? Okay, it's a crest. Okay. Okay, how about this one? Trough. Okay, not trough. Okay, trough. Okay, how about this one? All right, wavelength. Okay. All right, crest. And this one is trough. And this one is the wavelength. Very good, on-site students. Okay, now it's time for me to ask online students as well, right? Okay. Online students, let me ask this to Pang. Pang. Hello, Pang. Kaimuk. Hello, Kaimuk. All right, Kaimuk. What do you think this is? This part of the wave.
Amplitude.
Yes?
Amplitude.
Very good. It's called amplitude. All right. This part is called as amplitude. Okay. How about this one? Let me ask this to Pat. Oh, no. I want. Okay, Pat. Can you please answer this? Pat, what is this? Is it crest? Is it trough? Or is it is it amplitude? What is it, Pat? Hello, Pat. Teacher is waiting. Waiting game. Okay, Otto. Hello, Otto. What do you think this is? This part of the wave is called?
Curve.
Very good. It's called crest. Okay. Okay, very good, Otto. How about this one, Alex?
Yeah.
Alex?
Yeah.
What is this part of? Is it crest? Is it trough? What is it? Alex, teacher cannot hear you. I will give you options. Okay. Is it wavelength or is it trough? Is it wavelength or trough?
Truck.
Okay, it's trough. All right, very good. How about the last one? I want to ask this to Prow. Prow, what is this, Prow?
Yes.
Uh-huh.
Wave lake.
Think what? Only wave?
Wavelength.
Okay, very good, Prowl. It's wavelength. All right, everyone. Christoph, wavelength and amplitude. Okay. All right. So Chris is the top of the wave and trough is the bottom of the wave. So wavelength is the distance from one wave to another wave is called as wavelength. Whereas amplitude is distance from the middle line to the crest here is called as amplitude. All right. So last time, do you guys remember I showed you guys this video, right? Video of longitudinal wave and transverse wave. So this is a longitudinal wave or a transversal wave, okay? So the examples are water wave, light wave, and electromagnetic spectrums are the example. So what wave is this? It's is it transversal wave, right? Very good. It's a transversal wave. All right, everyone. See, this is how the transversal wave flows. All right. Okay. Next one. Do you guys remember this one? This is a longitudinal wave. So the example is sound wave. See, this is how the longitudinal wave flows. Understand, right? Longitudinal and transversal wave. Very easy. All right. Easy, right? So you guys are done with this, right? Okay. So today's topic is electromagnetic wave. All right. Okay. All right. So it's electromagnetic wave. So the wave, all right, it can be categorized into two groups. Okay, two groups. How many groups? Two groups. Okay, based on their ability to travel through the vacuum. So do you guys know this word? The word vacuum means into an empty space. Okay, is called as vacuum. All right. So wave can be categorized into two groups based on their ability to travel through a vacuum. It's called as the waves. All right. So what is this? Vacuum. So what is vacuum? Empty space, right? The vacuum means empty space. All right. So those two groups can be. The two groups are mechanical wave and electromagnetic waves. All right. Mechanical wave and electromagnetic wave are the two groups based on their ability to travel through an empty space or vacuum is called as is mechanical and electromagnetic wave. Sorry. Okay, so first let's look at mechanical wave. All right. A mechanical wave is a wave that is not able to travel through vacuum. They cannot pass through vacuum, okay? Understand, everyone? Mechanical wave. What is mechanical wave? What is mechanical wave? Empty space. The one that cannot pass through empty space is called as mechanical wave. Okay, the word vacuum means empty space. All right. So mechanical wave is a wave that is not able to travel through a vacuum. So what does it need to be able to travel through a vacuum? So let's see. It needs medium such as air and water. All right. Air and water are the two mediums. So the word medium here means the material in which the wave travels is called as medium. All right, everyone, the material in which a wave travels. So the material here is the, what is it? Air and Yes, so these two are the medium. All right. So since the mechanical wave cannot pass through the vacuum, they need a medium such as air and water to pass through. All right. So such as like the sound wave needs, what do they need? Yes, sound wave needs air to travel, right? Whereas water wave needs water to travel. Okay, so what do you think the examples will be for the mechanical wave? What do you think the examples will be for the mechanical wave? Tsunami. It's a water wave, right? Another can be, yes, another can be sound wave. Okay, the example of mechanical waves are sound waves and water wave are the two examples of mechanical wave. All right, understood, right, everyone? This one?
Yes.
Mechanical wave cannot pass through the vacuum. Okay, so they need mediums like air and water to able to pass through. Okay, so the example of sound wave and water wave are the examples. Next one is electromagnetic wave. All right, so I want someone to read. Hold on, I want online students to read. Pat. Hello, Pat. Pat. Kaimuk. Hello, Kaimuk. Okay. Kaimuk, can you please read the sentence for this electromagnetic wave?
An electromagnetic wave is able to travel through a vacuum.
Okay, very good, Kaimuk. So now, electromagnetic wave is a wave that is able to travel through a vacuum. Understand the difference now? This one able to travel through vacuum. Okay. So it contains, okay, electric field and magnetic field. Electromagnetic wave is able to travel through a vacuum, but when it travels, it contains electric field and magnetic field. Understood, everyone? Okay, this one is electric field and this one is magnetic field. Let's see what our electric and magnetic fields are. All right. So electric field, it creates electric charge in any charged particles is known as electric field. All right. So it has positive and negative charged particles. All right. So second one is magnetic wave. Can someone read? Ton, can you please read magnetic field? Moving. Okay, everyone. So electric field and magnetic field. Electric field will electric field and magnetic field, it creates electric charge in any charged particles. All right, whereas in the magnetic field it creates electric charge in the moving magnet. So the word, can you see this word field, right? So field is a region in which a force exerts, okay, on an object at distance is called as field. All right, everyone? So do you get the difference, everyone? Electromagnetic wave and mechanical wave. Okay, let me ask you guys a question now. I will ask you guys a question now. Okay. So the wave can be grouped into two, right? One is mechanical wave, another one is electromagnetic wave. So what is mechanical wave? Alex, what is mechanical wave? Mechanical wave. Is it the one that is able to travel through vacuum, or is it the one that is not being able to travel through a vacuum? I'm giving you two options. Okay. Yes. What is his name? Okay. Base, can you please tell me what is mechanical wave? I'll give you two options, okay? Two options. Is it the one that is being able to travel through a vacuum, or is it the one that is not being able to travel through the vacuum? Vacuum means empty space, all right? So what is it? What is the answer? Can mechanical wave travel through vacuum or cannot travel through vacuum? It cannot, all right? It cannot travel. So they need a medium such as air and water to be able to travel through, all right? Whereas electromagnetic waves are the ones that is able to travel through a vacuum. So when they travel, they contain electric field and magnetic field, all right? So, okay, there are many types of electromagnetic wave, okay? Electronic wave based on the wavelength and frequencies, okay? So I want someone to read this. Where is Otto? Otto, can you please read the 7 types of electronic waves? Otto, teacher cannot hear you. Oh.
Radio wave,
Mm-hmm.
microwave, infrared rays,
Rays.
visible light, ultraviolet rays, X-ray, gamma rays.
Okay, very good. And on-site students, I want every one of you to read this together, okay? So please read this. Look at the screen. All right, very good. Radio wave, microwave, infrared wave, visible light, ultraviolet rays, X-rays, and gamma rays are the 7 types of electronic waves. Okay, everyone? So we will learn about the 7 waves in our next class because we are running out of time. All right. So with this, I want every one of you to turn to this page. Everyone turn to this page. Online student, turn to this page. Page number 68. Wait, base and what is his name? Please turn to this page. 68. Finished? All right. Okay, I'm gonna read out and you're going to tell me the answer, okay? A dashed wave is a wave that has vibration in direction dashed to the direction of propagation of the wave. So what is it? A dash wave is a wave. What wave do you think is it? Is it transverse or longitudinal wave? What is the answer? It's, can you see this? What wave is this? Transverse or longitudinal? So the answer is, okay, transverse wave is a wave that has vibration in the direction. Do you remember the word? Perpendicular, okay. In the direction that it moves, okay? Or a propagation of the wave. Examples of the waves are water wave, and it can be sound wave, and there can be electromagnetic wave. You can write sound wave also. It's correct answer. Okay. B. A dash wave. What wave is this? Very good. It's a longitudinal wave. It's a wave that has vibration in the direction. Is it parallel or perpendicular? Sideways, right? So what is this? Yes, parallel, okay? Parallel to the direction of the propagation of the wave. An example of this wave is Plawan. What is the example of this wave, Plawan?
Okay,
Uh-huh.
it is
Wave. What is it?
no,
It's a sound
Transverse.
wave. All right.
Okay.
Please write this, everyone. The word perpendicular means 90 degree up and down. Okay. The word parallel means sideways. We have 3 minutes. Online students, are you guys done writing? Alex, are you finished?
My book execution.
About to, right? Okay, so I'm gonna change it, okay? So next one is on page number 71. 71, 6.2. Exercise 6.2. Page number 71, activity 6.2. There are two types of waves, right? Based on their ability to travel through a vacuum, okay? State the type and give an example of each wave. Okay, listen on-site students. A, able to travel through vacuum. Is it electromagnetic wave? Yes, it is, okay? So the answer here is electromagnetic wave. And then examples, I give you 7 of them, right? That time, so you can choose any one, okay? So I choose here visible light for now. You can choose any examples from there. How about this one, B? Not, yes, it's mechanical wave. Very good. An example is, very good, sound wave. Online student, please write this, page 71, all right? We have 1 minute. I'll give you guys 20 seconds to write this. In our next class, we will learn about electromagnetic waves. Okay, they're examples. 7 of them, right? You done? Bring your book. Bring your book. Let me check. How about the last class? All right. Online student, we have less than 1 minute. So if you're done, you are free to leave the Zoom classroom. I will see you guys next Wednesday. Bye-bye.